Okay children, let's move to our session. Chapter 1, Electric Charges and Fields, Part 2. Today we will talk about Coulombs law. Coulomb, as you know, is the name of a scientist. You are familiar with this name, Coulomb. Coulomb is the unit of charge. And you had studied about charge and its unit in your class 10 physics. Okay, so Coulomb's law is a quantitative statement of force between two charges. Quantitative statement means what? Coulomb's law helps us to quantify, or it helps us to find out or calculate the amount of force present between two stationary charges. Stationary charges means charges at rest. Before discussing about Coulomb's law, we must know the concept of point charges. When do we consider charges as point charges? When the distance between two charges is greater than the size of the charges. In such situation, charges can be considered as point charges. So consider this figure. Here, Q1 represents one charge. Q2 represents another charge. Let R be the distance between the centers of Q1 and Q2. Here, it is clear the distance R is very large compared to the size of the charges. In such situation, Q1 and Q2 can be considered as point charges. Okay, so consider such two point charges separated by a distance R in vacuum. Here, Q1 exerts a force on Q2. Q2 in turn also exerts a force on Q1. And what is the nature of force? That depends upon the polarity of the charges. If Q1 and Q2 are like charges, then the force present between Q1 and Q2 will be repulsive, because you know like charges repel each other. But if Q1 and Q2 are unlike charges, then attractive force exists between Q1 and Q2. As you know, unlike charges attract each other. However, a force is present between Q1 and Q2. It can be attractive or it can be repulsive depending upon the nature of or polarity of the charges. Since these charges are at rest, the force exerted between, or the force existing between these two charges can be considered as electrostatic force. The word static itself implies stationary or at rest. So Coulomb has made a statement regarding the electrostatic force present between these two stationary charges. The statement is like this: the electrostatic force between two stationary charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of distance between them. So this electrostatic force is directly proportional to product of charges. At the same time, it is inversely proportional to the square of distance between them. So how can we express this statement mathematically? It's very important to know the mathematical expression for Coulomb's law. So next, let's see the mathematical expression for Coulomb's law. See, in the statement, it was written like this, that is, force is directly proportional to the product of charges. So Q1 is one charge, Q2 is another charge. Their product is Q1 into Q2. The force is directly proportional to the product of the charges. Also, force is inversely proportional to square of distance between them. So R is the distance between the charges. Square of R means R square. So F is inversely proportional to R square. Combining these two expressions, we will get force is proportional to Q1 Q2 by R square. And from this expression, it's very clear that force is directly proportional to the product of charges, and at the same time force is inversely proportional to the square of distance between them. And you know, we need an expression or we need an equation. So we need to remove this proportionality symbol. So what is the usual way? Add a constant. Here we are adding a constant K. K. And K is known as the dielectric constant of the medium. What is dielectric constant and what is its property? All those things we will discuss in detail later. So this is the mathematical expression for Coulombs law. F is equal to K Q1 Q2 by R square, where K is the dielectric constant of the medium. There is an expression for K, and K is calculated using the expression 1 by 4 pi epsilon naught. This symbol represents epsilon naught, and this epsilon naught is known as permittivity of free space. It has got a constant value. It's a constant. Epsilon naught is a constant, and it is known as permittivity of free space because we have considered two stationary charges in vacuum or in free space. Free space means vacuum itself. So epsilon naught is the permittivity of free space. Its value is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. This value is always constant. The value of epsilon naught remains the same. Okay, and its unit as well as its magnitude is very important. You must remember its magnitude and unit. So epsilon naught, the value is 8.85 into 10 raised to minus 12 and its unit is Coulomb square per Newton meter square. So K is equal to 1 by 4 pi epsilon naught, and when you substitute all the values, because 4 is a constant and pi, you know the value of pi 3.14 or 22 by 7, you can substitute any one of the expression for pi, and now you know the value of epsilon naught. So substituting all the values here in this expression, you will get the value of K equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. So this is the value of K, dielectric constant, 9 into 10 raised to 9 Newton meter square per Coulomb square. So just remember the value and unit of K. Okay. So how can you write an expression for force? Again, force F is equal to K Q1 Q2 by R square, and what is the value of K? 1 by 4 pi epsilon naught. So F equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. Now you know the value of 1 by 4 pi epsilon naught. What is the value of 1 by 4 pi epsilon naught? 9 into 10 raised to 9, then Q1 Q2 by R square. So this is the expression for Coulombs law, mathematical expression for Coulombs law. Suppose the charges are not in vacuum, the charges are in a medium. So in such cases, what will be the expression of electrostatic force? Electrostatic force F, the expression can be written like this: 1 by 4 pi epsilon into Q1 Q2 by R square. See here, we didn't write epsilon naught, we are writing just epsilon. This epsilon represents permittivity of the medium. Whatever medium we have taken, it can be air, water or oil, glycerin, anything can be a medium. Okay. So this is the mathematical expression for Coulombs law if the charges are present in any medium, not in free space. And previously we have found one expression that this is the mathematical expression for Coulombs law if the charges are present in vacuum. Okay.